Howdy. So today we are going to do a electricity lab, and we're going to do it in the class and asynchronously at home. And so let's start off with what the heck is a battery, and what are the parameters that we're going to be studying with batteries. And so here I have a battery and I have some wires. And so in the actual lab in class, you'll be doing something similar to this with real wires and real batteries. All we're doing is we're constructing wires, and the wires are just going to make what's called a circuit, and they just allow the electrons to flow through. So what do I mean allow the electrons to flow through? Well, there's no circuit here. So let's go over to this one for a second. A battery is a situation where you have a chemical situation where there's electrons which are negative, and they're kind of highly packed into one side of the battery in large amounts, and they really badly want to get through the circuit to the other side of the battery. I almost want to make that a different color, right? Just so I can show you the electrons traveling through. So the electrons, they want to go through this circuit to the other side, and that allows them, when they're going through, let's say this is a light bulb here, when they go through here, they meet some resistance, which in this case causes heat and light. And so this light bulb will light up because the electrons are trying to get through this light bulb filament. And when it goes through, it gives us work. This voltage potential is a lot like gravitational potential. So which way did he go, George? This is the potential energy. The electrons are almost like they're at the top of a ramp. And as they go down the ramp, we can make them do work for us. But in this case, the work that they're doing is electrical work, right? And basically run a vacuum cleaner, or heat up an iron, or light your room. And so there's three things that we look at with respect to the first one is volts, and that is the potential energy that we have. And volts are measured in V, voltage. The second thing we have is called current. And I don't know what color to use for current. Maybe I'll use a blue, like a river. So the second one is actually the letter I, and that stands for current. And current is measured in amperes or amps. And so we just use A for amps. And that is actually how many electrons are able to run through this circuit at one time. So the electrons will run through, but how many kind of depends on your highway. It's almost like if I have a one-lane highway versus a two-lane highway, more electrons can go through. And so the electrons are running through this circuit from one side of the battery to the next. It's making some light here. So let's watch over here. Let's watch the electrons run through. So I don't have a light on here. So it's going through so fast that it's causing the battery to overheat. So I want to stop that for a second. I'll put a light bulb on there this time. So I got my light bulb, and I'm going to connect it to both sides. And there we go. The electrons are moving through the system, through the circuit. Right here in this part of the circuit, there's a little bit of electrical resistance, and that resistance is causing heat and light, and that's how light bulbs work. Okay, so in this case, I've almost, I didn't talk about resistance. And so right here we have what's called resistance, and resistance is resistance, and resistance is the letter R, and it is actually measured in what are called ohms. And ohms is this little symbol here. And so there's a lot of like little words you need to know here. That's ohms. And so in a second, we're going to go back here and we're going to kind of like make sure you know what's going on with what's going on with a circuit. But just to kind of like give you the overview one more time, I got my voltage potential, which is provided by my battery. They have electrons inside. The electrons want very badly to get to the other side of the battery. And if it runs out entirely, it'll be a dead battery. But right now it's a full battery, so all the electrons have the potential to move their side. Then I have once I make a circuit, the electrons can go through, and that's called current, and that's measured in amps or amperes, and it's the letter I. Um, if I have resistance, it slows down the flow. So resistance slows down the flow or slows down the current, and usually produces heat, or could be light or something like that. And that is measured in ohms, resistance ohms. And so those are the things that you have in the circuit. One last thing is interesting to note is the people that originally were studying electricity didn't realize what was moving. They thought positive charges were moving, because they didn't know much about electrochemistry. They didn't know much about the atom. And so if you look at if I click this button back and forth, it shows that conventionally we think that the energy is running from positive to negative like this. And because that's what people thought was happening. They knew there was a flow of something. But the reality is that electrons are negative. So electrons are actually running the opposite direction of the current. You don't really need to know that too much. It doesn't really affect it. In fact, when you make measurements, what it will do is it will change the sign if you just reverse. And I can't remember if this one actually works, but if you go like this, yeah, it does work. It just reverses the sign. So every number that you would use in a circuit would be the correct number, but if you know, it's just a direction. Basically, do you remember how we always use signs to denote direction? And so that's really the same here with electricity. Is I reverse the direction and I reverse the sign. So that's the first part of what we're doing for electricity.